Okay, this lesson is going to be about programming patterns. These patterns just show up regularly. They almost always repeat. So if you want to improve your coding, I suggest you actually do these two and kind of get used to the pattern because they just keep repeating over and over again. So the first programming pattern we're gonna solve is called mapping. So in the first exercise, it says write a function second ls that takes a list of tuples and returns the list with the second element of each tuple. Returns the list with the second element. So, okay. So we want to define a function called second ls. Define and create a list called L. Let's do it. And for I in ls, L.append I. So it's a tuple. Tuple. I think this should work. Then return L. So print this should give me the same as the answer over here. So it should be true. Okay, I see. I always get confused. I think tuples are written with parentheses, so not like that. That's not what I meant either. It's annoying. I1 L.append I1. Yes, finally. I don't know why I didn't get it correct for in the first try. Alright though. Exercise 2. Write a function toText ls, so define this function, that takes a list of numbers between 0 and 9 and returns the list of numbers as text. Use a dictionary to do the conversion. Okay. This is going to be a little tedious to do, and I don't want the video to be too long. So I'll ask GPT to send me a dictionary where it is number then 1 to 10, I think. 1 to 9, yes. Yeah, otherwise it's going to take too long. So I'll just do it like this. Yep, this is going to do the job and save a lot of time. So for I in ls, if I in number.names, hold on, from 0 to 9. Change that quickly. I mean, if this wasn't the exam, just you gotta do the tedious task. So if I is a number names, it's also good if we just create another list. L dot append ls I, so it returns the value and then return L at the end. Then this should do the job. Print, there we go. Index is out of range for some reason. Oh, I get it, I get it. Yep. So that should give us 0, 1, 3, 6, 7. Exactly what we wanted. So we can continue to exercise 3. So write a function multiplied by ls and then factor. So define multiplied by that takes a list of numbers and returns the list where each number is multiplied by the factor. So let's create another list. Then for I in ls, L dot append I times factor. That's what we want. Then return L. That's all we want. So print this should be equal to this over here, and it is true. So this is how you solve this. Now our second programming pattern is filtering. So let's start with exercise number 1. Let's define this function. So write a function that takes a list of numbers and returns only the positive numbers. Okay, so what we have to do is just create an empty list. For I in ls, if I is bigger than 0, L dot append I, then return L at the end. Oh, I didn't want to do that. Quit interactive mode. Yes. So if I print this, this should give me 2 and 4, which is exactly what we expect. So let's begin with exercise number 2. Write a function higher than. Write a function higher than that takes a list of numbers and the threshold number, and only the numbers that are higher than the threshold number can be passed. Okay, so it's basically the same logic. Create an empty list. For I in ls, if I bigger than num, then you want to append it, then return L, then print whatever you have here. Which is 20, 30, and 40, which is exactly what we expected. So last exercise of this pattern technique. So let's define our function. Write a function short names ls that takes a list of names and returns only the names with fewer than 5 characters. So this is also really easy. So what we want to do is L, again, create an empty list. So for I in ls, if length of I is smaller than 5, then L dot append I, then return L. This is what we want to do. Then print this. John, Amy, Tom, which is exactly what we wanted. So that's awesome. Let's go on to our new programming pattern. This is called aggregation. So write a function count true ls. Let's define our function that takes a list of Boolean values and returns the number of true values. Okay, count true. Okay, so we want to create a count number. Count is equal to 0. For I in ls, if I is equal to true, count equals count plus 1. Else you want to continue, then return count. So printing this should give us 3, which it did. Exercise number 2. Let's copy the function down. Write a function total length that takes a list of strings and returns the total number of characters across in the string. Okay. Total is equal to 0. So for I in ls, total is equal to total plus length of I. That's all we want to do, then return total. So printing this should give us 15, which it did. Okay, now exercise 3. Write a function sum positives ls that takes a list of numbers and returns the sum of all positive numbers. This requires that you combine the filtering of the aggregation patterns. Okay, awesome. So we can create another list called L for I in ls. If I bigger than 0, L.append I and return sum. We can just return sum of L if we want to just play easy. I'll show it that way too. Print exactly, but we could also just do this for I, for let's do K in L, total equals 0. Total equals total plus K, then we just return total, which is also going to give us the exact same answer, 10. So let's go to exercise 4. Let's define our function first. Let's put it quickly. So write a function total length short names ls that takes a list of names and returns the number of characters across names shorter than 5 characters. Note this requires combining this. Okay. Alright. L is going to be a list. So for I in ls, if length of I is smaller than 5, then L.append I. Then for K in L, total is equal to 0. Total is equal to total plus length of K. So then if we return total, then it's going to give us the addition. Well, that's not what we're supposed to copy. My bad. print, so printing this. It was meant to give us oh, of course, because it's the wrong function. Total underscore length short names. Then it is going to give us 10. Yep, that is what we wanted. So I think this is our last programming pattern. I might be wrong though. I think I'm wrong. Yeah, we have 2 more programming patterns left. So looping with a counter. This is our next programming pattern. So let's begin. How many exercises do we have? 4, okay. All right. Write a function called this. Let's define a function that takes a list of numbers and returns the positions, indices of the positive numbers. Okay. Interesting. Let's do an empty list for I in ls. If I is bigger than 0, so it's positive, l.append ls.index I think is going to be the correct way of doing this. Then return L should actually give us the correct answer, hopefully. But this is looping with a counter. Okay, I used the wrong programming pattern basically. So yeah, I mean, I still got the correct answer, but let's actually use the counter. So for I in range length of ls, it's supposed to start from 0. If I is bigger than 0, we've got to define our empty list. L.append ls lsi. Then if we return L, well, it didn't give us the same answer, did it? Gives us 0. Oh, of course, of course. Of course. Interesting. How can I fix this? I guess I could do this. I mean, at that point, why don't you use a for loop, I guess? Simply this could solve the issue. Exactly. Did it though? We got 4, 7, and 2. Oh, of course, we had to do ls.index then we get 2.245. Right, so that's how we do it. So this was exercise 1. Let's do exercise 2. Write a function positions of spaces. Define positions of spaces that takes a string and returns a list of positions indices where spaces occur. Okay. Hold on though. What was this called? Looping with a counter. I'm curious about something. Filtering, aggregation, looping with a counter. Yeah, looping with a counter means we need to use for I in range. Interesting. Sometimes I feel like not using I in range is going to be better, but okay. For I in range, the length of S, I think it's called, yep. If Si is equal to basically a space, then L dot append, we could append simply I, which is going to be the position, then we can return L. And hopefully I at least did this correctly. We print this position. 5, 11, 16, exactly, it was correct. Great. So exercise number 3. Just copy a function, define it, write a function, differences ls, that takes a list of numbers and returns a list of differences between each number and the previous one. Start from the second position of the list. Okay, for I, and for I, I'll also do count equals 0. For I in range, length of ls, then we want to start from the second element. Okay, interesting. L dot append, we want to append the difference between that. So ls I subtracted by ls count. But we also want to do count equals count plus 1. Then return L at the end. Hopefully gives us the correct answer. Yep, it does. Awesome. All right, last exercise of this programming pattern. So let's define our function. Write a function prices increases prices that takes a list of tuples where each tuple contains a day and the price, example Monday and 100, and returns a list of days where the price increased compared to the previous day. Okay, for I in range, length of prices, then we can also start this from 1. if of course, so if the prices includes day 2, so the second item's second item, if this is bigger than prices I minus 1's second item, then L dot append prices then return L. Hopefully this will be correct. Print we get an error, okay. Integer object is not subscriptable. Is that because it's a tuple? I think I definitely need how to call tuples. I definitely need to learn how to call for tuples. So it's a list. So the first items I think I get it. This is something I need to learn really well, to be honest. Yep. That gives me the prices, but I want the days. I don't want that. What did it give me before? It ends with a 7. So this is new. I want the days. Mhm. Oh, of course. That's because I need to put 0 here. Yes, Tuesday and Thursday. So this is how we get this. I always get confused as to why this works like this. I'll honestly study that a bit more. But anyways, our last type of programming pattern is called naive search. So define, yeah, this is gonna be really easy. So like just return the first negative number. So for I in ls, if I is smaller than 0, return I, and if none of them is, return none. This is gonna work. I didn't read the question because it was too easy. But of course, imagine if I flop here. Yep, -4. Find first occurrences. Define this. That takes a string S and the character and returns the first occurrence of that string in that string. If the character is not found, return none. Okay. For I in character, if I is equal to S, return I. Return none. Yep. So printing this should give us. Interesting. What did I do wrong? Interesting. This is really interesting. I actually don't know why I got this wrong. It's really late right now. Maybe my brain is just not functioning. But I'm just gonna debug because why not? What? Oh, it's because S is longer. That's so stupid. Yeah. Now it works. Of course it does. Okay. What is the definition of this? All right. Write a function find ID of first customer named customer name that takes a list of tuples, ID and name, and a string name, and returns the first customer whose name matches the given name. If no such customer exists, return none. Okay. For I in customers, if I1 is equal to name, return name. What do you mean? I don't get this. Returns the first customer, return I. Okay. Print this. Yep, now it's correct, but if it doesn't exist, then return none. Return none. Yep, so this is how it is. These are all the programming patterns there are. I hope this was useful. If you actually solve these questions yourself and get really good at them, I think many of the questions you solve later on in your coding journey are gonna start to make more sense. So I hope this was useful. See you in the next one.